Okay, so we're going to be going, this is section 1.4, number 6, 8, and 11. Per one of your classmates had this request. So I'm going to go over these really quick. Not really quick, just I'm going to go over them so you have them in your head. I was telling the student that this is not a main player on our quiz tomorrow. So if you're like, oh, I don't know how to do this, it's not a main, it's not the main character at all. Meaning like, if you don't know how to do this, you can still get an A on the quiz. Okay. So I'm always going to go back to the definition whenever I do these things, because the definition, I don't like the rules, because the rules, if you only remember part of the rule, like for example, my students always tell me like, hey, Ms. Johnson, isn't a negative and a negative a positive? And that's true when you are multiplying. It is not true when you are adding. So if you forget the when, then your rule, as good as it is it will lead you to a wrong answer. So I don't really like rules. If you understand the rule because you remember, great. But if you don't remember, then I always go back to the definition. Okay, so here, if you remembered our conversation from before, this guy here is the problem, our negative exponents. So negative exponents. So if you think about, like, remember back in scientific notation days, the negative exponent means that the number is going to turn smaller. And the way we turn numbers smaller in exponent land is we make them fractions, means fractions. Some kind of fraction is going to be present. Okay, so when I see 2 to the negative third, and we talked about this in the other video, if you look at 2 to the negative third, we come up with why that is. And I think I put it up here, right? We talked about what negative exponents mean. It's because we're dividing. If you go up, you're multiplying by 7, right? Multiply by 7, multiply by 7, multiply by 7. But if you go down, like from 7 cubed to 7 squared, notice you're dividing a 7 out. Dividing a 7 out. That's why 7 to the 0 is 1. And we divide by 7 again. So if you think about 7 to the negative third, if I was to write that out, it would be 1 over 7 times 7 times 7. 7, I have 3 sevens on the bottom now. So if you think about what this negative exponent means, what I'm telling you, it means fractions, small numbers. I'll write that too. Small numbers. Then it makes sense that 2 to the negative third really just means 1 over 2 times 2 times 2. Okay, so that's what that means. So this part right here. Once you have this part in your head, the rest of this problem becomes fairly simple, right? So now that I know that this is 2 to the negative third means 2, 2, 2 on the bottom, then I can write the rest of these 2's out, right? So here, 2 to the 6th looks like this. 1, 2, 3, 4, 5, 6, and it's being multiplied. And then I have this extra 2 right here, right? And then I go back and I fill out the 2, 2, 2 on the bottom from there. Okay, so what does this mean, Ms. Johnson? So these 2's here came from that 2 to the negative 3. And then just as you remember, 2 to the 6 just means 2 times 2 times 2 times 2 times 2 times 2. And then that 2 is just hanging out here. As you can see some of these canceling out or dividing, and this is actually just a 1. This right here cancels with this right here, leaving a 1, right? So then I'm left with 2 times 2 times 2 times 2, which I know is 2 to the 4th. So here, if you read the directions, it says use the product rule or quotient rule to find the expression. Leave all answers in exponential form with only positives. And so if you think about what you did, you can come up with that rule. You can come up with that rule of what you do with exponents when they look like this. Okay, so that's the thing that I want you to think is like, okay, well, where do I see that 4 here? Where does that 4 live? And I'll give you a little hint. You had to remember that that 2 has an invisible exponent of 1. Okay, so think about that. I'm not a huge, I'm going to say this again and again, I'm not a huge fan of memorize the rule. because that has shown to be, what is the right word? That has shown to fail during a quiz, right? Okay. Number 8, if you take this number 8 in exactly the same fashion, you'll see some like this area right here where they actually divide out to be the number 1, right? 2 times 2 times 2 divided by 2 times 2 times 2 leaves you with a 1, right? 2 divided by 2 is 1. So try this one, like pause the video, try this one and see if you can come up with the right answer. Okay, so okay, so now that you're back, you've tried 7 to the 5th and 7 squared. So it should kind of look like this. 7 to the 5th is 7 times 7 times 7 times 7 times 7 over 7 squared, which is 7 times 7. You should see that these would make a 1, right? 7 times 7 divided by 7 times 7. Oops, it's not catching up. 7 times 7 and 7 times 7, they would cancel to be a 1. So imagine that's just a big 1. And that's 1 times 7 times 7 times 7, which actually equals to 7 cubed. And if you look, again, you're looking for patterns. Where do you see the 7 in the answer in the problem? Oh, I see it. Where do you see this 3 in this problem? That's what you're looking for. How did she get that 3 without having to go through the definition there? And there is a rule to do this, but again, I'm anti-rule because the rule, if you don't remember the rule or you remember the rule wrong, you'll get the wrong answer. So again, how do you see this 4 in this whole thing? Okay, this one here is really interesting because you got negative exponents, you got fractions. It's very interesting. So I'm going to take the 7 to the negative 4th first. Okay, 7 to the negative 4th, we talked about earlier, means that the 7s are going to go on the bottom. Okay, those 7s, these 7 to the negative 4th is going to go on the bottom. So this guy here is going to go on the bottom, right? So that means here's my line. Here's 7 times 7 times 7 times 7. That makes sense. But then when it flips and you're like, okay, but Ms. Johnson, what do I do with these 7s that are on the bottom that have a negative exponent, right? Because you told me negative exponents means fractions, right? And this is almost like dividing by a fraction. If you think about what dividing by a fraction is, you're really multiplying by the reciprocal. So that should kind of give you a hint on what's happening here. So if I asked you, I have $4 and I want to split it up into $half, right? How many $half do I have in $4? You would be like, well, there's 2 in the first dollar and then 2, 2, 2. So that'd be 8, Miss Johnson. There'd be 8. And so notice how your number is getting bigger, right? And you're like, but Miss Johnson, you said it's smaller. But yeah, this number in itself is smaller. But when you divide by a smaller number, the quotient actually comes bigger, right? So your reminder of that is 4 divided by 1/2 is 8. Right? 4 divided by 1/2 is 8. Okay, so then why, Ms. Johnson, so what happens with this? Well, the 7s are going to go on the bottom of the bottom. So when you think about that, that's when you multiply here by the reciprocal here. The bottom of the bottom, can you imagine this being written as 4 divided by 1/2? Right? The bottom of the bottom goes to the top. I know that sounds funny. All right, so this guy here gets moved up here. 7 times 7 times 7 times 7 times 7, shoot, times 7. Wait, 1, 2, 3, 4, 5, 6, 7, and 8. Ah, I can't fit another 7 in there. Okay, I did. I squashed them in there. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, perfect. So all of those go up there to the top. Does that make sense? And now you can kind of see, oh, Ms. Johnson, I see it. I see it. I see that I'm going to be able to cancel or divide. What is happening, computer? I'm going to be able to divide these out to be a 1. And there I am, I'm left with 7 to the 4th. So again, your job is to try to figure out how do I go from here to here, right? From 7 to the -4th divided by 7 to the -8th to 7 to the 4th, right? I'm trying to figure that out. What pattern do you see? And that same pattern over here should exist over here. And you'll see that pattern. Again, I'm not a huge fan of telling you it, but just go back to your definition all the time. I'm a huge fan of that. And if you don't remember that, no problem. Actually, if you go back to the definition of things, you'll have to remember a lot less. The rule makes you think that you'll have to remember less than the definition. That's not true. Okay.